All right, let's take a look at question 5 from the 6.4 homework. Assume that the amounts of weight that male college students gain during their freshman year are normally distributed with a mean of 1.2 kilograms and a standard deviation of 5.7 kilograms. So, complete parts A through C. If one male college student is randomly selected, find the probability that he gains between 0 kilograms and 3 kilograms during freshman year. So I just put that information down, and I'm going to use that information to go to StatCrunch. So let's go ahead and do that. Let's go to StatCrunch. Then we're going to go to Stat, Calculators, and then Normal. And we're looking for, so we have a normal distribution with a mean of 1.2. Now notice the fact that the standard deviation is actually greater than the mean, which means that there will be some negative values as a possibility. 5.7 kilograms. Like, what I mean by that is this. If the mean is 1.2 and the standard deviation is 5.7, one standard deviation above the mean will be 1.2 plus 5.7, which is 6.9. But if you go one standard deviation below the mean, you'll have 1.2 minus 5.7, which I'm calculating now, is equal to negative 4.5. So just one standard deviation below the mean is a negative number. In other words, what that means is that there's, the possibility of losing weight is entering the equation. So now we want to hit the between button, right? And we're looking for the values to be between 0 and 3. And we'll hit compute. And so, with a mean of 1.2 and a standard deviation of 5.7, the probability that a single student will gain between 0 and 3 kilograms is 0.2073. So let's go ahead and enter that number, 0.2073. Now, in part B, we're looking at 16 college students. So now we're looking for the mean weight gain of a group of 16. And that's where the central limit theorem comes into play. Now you notice that in the statement of the problem, it says that the weights are normally distributed. So we can in fact use the central limit theorem even though the number is less than 30. So we're going to write n is equal to 16. So what's the difference between part B and part A? The only thing that's different is the fact that the standard deviation has to be adjusted for the sample size. So in other words, we have here, I'm going to bring it over here. So it's the same problem, right? So the standard deviation of X bar, the mean of X bar will remain 1.2 kilograms. But the standard deviation of X bar has to be adjusted for the sample size. So our standard deviation was 5.7 kilograms, but we have to divide that by the square root of n. So we're going to get 5.7 divided by root 16, which is just 4. 5.7 divided by 4 is equal to 1.425. So now that is the standard deviation we need to use when we put this problem back into StatCrunch. So I'm going to pull StatCrunch back up, and we still have a mean of 1.2, but now I have to adjust the standard deviation because I'm looking for the standard deviation of the mean of a group of 16. And now we get the probability that the mean weight gain is between 0 and 3 kilograms is 0.69 0.69. So let's go ahead and enter that in here, 0.6969. And then, of course, the normal distribution can be used in Part B because they state that the amounts of weight that male college students gain during the freshman year is normally distributed. So they tell us. So it's not Part A. It's not Part B. So let's try Part D. Since the original population has a normal distribution, yes. And that concludes this lesson.